Welcome to the lesson, Racing Turtles. The lesson can be used to deepen the students' understanding on the topic of perimeter, and it can also be used to introduce the topic itself. As you will see, the only prior knowledge the students need to have is a basic understanding of area. The questions in this lesson will focus on comparing the perimeters of two shapes. Let's move on to the first question. At this point, read or have one of the students read this question for the class. Here are two racetracks. Two turtles start racing at the same time and at the same speed. One encircles the purple track, and the other encircles the green track. Who will be the first to complete a full round? Note that the point here is not to pose a motion problem for the students. The question is phrased this way so the students can answer it intuitively, even before we formally introduce the term perimeter. Now, the turtle with the shorter perimeter is the turtle that will finish first. Wait for the students to give their answers. Some students may answer that the purple shape is bigger. In this case, ask them what do they mean by bigger. They might be thinking about the area. The students can find the area by counting the squares. We can also use this tool, Show Hide Area. We click the purple shape, and we see its area is 11, and the green shape has an area of 5. But what you want the students to figure out is that what's important is not the area inside, but the length of the perimeter. If you're using this lesson to introduce the topic of the perimeter, this is where you can first use the term. You may call on one of the students to show the perimeter on the shape, and the student could trace it on the shape with his or her finger. After this, you can show an animation that will help them make this clear for the whole class. So we move to Turtle Controls and click Play. So the students can see the meaning of the perimeter and also easily count the length units. 1 blue, 1 red, 1 blue, and so on. And we can see that the perimeter of the left shape is also larger, 16 versus 12. The students may easily make the mistaken assumption that if the area of the shape is larger, its perimeter will be larger as well. So one of the goals of the lesson will be to dispel this mistake. Let's move on to the next question. This is a preparation for the question on the next page. Read the question to the students. On the next page, you will see two tracks, Track A and Track B. Your task is to answer intuitively without counting the segments which track is longer. Once you see the tracks, you will have 10 seconds to write A or B on a piece of paper. So the students get their piece of paper ready, and we move on to the next page. And the students see the shapes, and we click Start. Now the students don't have a lot of time, and the area of the left shape is indeed larger, so they might choose it because of that. Well, the time is up, so continue to the next page. And now we can see what the students wrote on their notes. If the students request it, you may go back to the previous page for a few more seconds. Now we continue. Since we know the area may confuse the students, we ask about it first. Now we will save time and simply show the areas. Before we move on to the turtle controls, ask the students to try to count or calculate the perimeters of the two shapes. We want them to feel surprised when they find out that the perimeter of shape A is smaller. Now move the turtle controls and click Play. See, when students are surprised, they are more interested in seeking out a solution to what surprised them. In the next page, we will see a case where the students will find it easy to understand how the area can be smaller while the perimeter larger. Ask the students, what shape has a larger area? In this case, the answer is clear. B is missing a square. Let's show the areas. In class, we can have a longer discussion. Now we'll simply click Turtle Controls and Play. We could stop at this point and notice that turtle A is ahead, and we understand why. B had a detour. Let's continue. And the perimeter of B is larger. We will now use another tool, movable lines. We can click it, and now the shapes are covered with segments that we can move. So we'll move this one here, and we can see the two extra segments that make the perimeter longer. And here is the next question for the students. The area of the green shape is obviously much larger, but at this point, the students will probably be more careful about relating this to the perimeter of the shapes. You can expose the area of the shapes to see a dramatic difference. Now we can move to Turtle Controls and click Play. As the turtle moves, you may ask the class to say stop when they're able to answer the question of which track has a larger perimeter. We are hoping the students say stop over here. Ask the student who said stop how he or she reached this conclusion. The student could say that in both shapes, the remaining path is the same as the path already traversed. If the students do not say that, you can introduce the topic of symmetry that applies to this case. So, if the perimeter of half the shape is 14, then the perimeter of the entire shape is 28. And this is true for both shapes. The perimeters are identical. Now we can click play and increase the speed to 5. And our conclusion will be verified. And now we move on to the student worksheet. This is one page with 3 tasks that we print out. Here it is. We first want the students to make an intuitive estimation of what shape has a larger perimeter. Tell them it's okay if they make a mistake. It's just interesting to see the difference, if there is any, between the first intuition and the later calculation. Next, we want the students to do the calculation and find the perimeter of both shapes, but also try to shorten the calculations like we saw in the example. We will review these 3 questions back in the app itself. And the next page. If you'd like, you can first present the area of the shapes, which will, of course, be dramatically different. Now the students will present their solutions and then show the turtle. And we can stop the turtle over here. And like the case in the example, we can identify the middle of the path. So the path yet to be covered is the same as the path already covered. And we see that even with the dramatic difference in area, the perimeters of the 2 shapes are the same. In class, you can have the turtle run all the way to the end. Here, we'll just continue to the next question. Again, ask the students to present their solutions. And when you're ready, you can run the turtle. You can ask the students when to stop the turtle for the purple shape, which is here. This is half the path, so the total perimeter will be 22. But on the green shape, we can make no such shortcut. Let's continue with the turtle all the way to the end. And we may see the perimeter of the left shape may be surprisingly long. And now the last question. Again, you can have a class discussion and then run the turtle. And play. And again, it's interesting to stop the turtle here. You can point out that the segments here are 1, 2, 3, 4, and here we have the same segments in a different order. 1, 3, 2, 4. And of course, the perimeter will come out to be the same. Let's continue to the summary. So in this lesson, we explained the meaning of a perimeter of a shape. As we mentioned, the lesson can be used to introduce this term. We found the perimeters of some shapes. We saw that having a bigger area does not necessarily mean having a larger perimeter. This is an important misconception that needs dealing with. And finally, we saw examples where using symmetry can shorten calculations. We hope you and your students enjoy this lesson in class.